So in this tutorial we're going to use a lot of the tools that we've already looked at, but we're going to bring them all into play on a single project. So in this project we're going to use the sensitivity tool, we're going to use the feasibility tool, and then finally we're going to run an optimization bearing in mind the results of the previous two analyses, so the sensitivity and the feasibility. The part that we're going to work on is a model of a crankshaft, and essentially we're going to try and minimize the mass of the part overall, and we're going to try and bring the center of gravity of the crankshaft in line with the central axis of the main bearing. So with a crankshaft, that's what you'd be looking at, because obviously any out of axis mass will cause the crankshaft to wobble. So you would want the center of gravity in line with that center axis of the crankshaft. So if you want to bring the crankshaft model in, it's called crankshaft PRT, and it should be in the behavioral modeling folder. So I'm just going to bring that in now. So here's our crankshaft, and then we're just going to run through the tutorial, just basically mirroring the steps that are described in there. So the first thing that we're going to do is disable all datums. I think that's what it says in the tutorial. In actual fact, I think we'll put the point display back on. It doesn't tell you to do that in the tutorial, but it will be useful for this next step. So we're going to create a datum point that represents the center of gravity of this part. So we're going to go into analysis, we're going to use the mass properties option here. We're going to generate the feature, or have a preview of what the feature is going to tell us. So the mass is in there, the center of gravity is in there. We're going to create a feature from this, so we need to select feature from the drop down list here, and then we can go in and select the pieces of information that we want in this feature. So we've deselected everything in this top window. You can see that we've got nothing selected there, and the only thing that we do want to select is this one, which places a datum point at the center of gravity. So when we OK that, you can see that that appears down here as a feature. It's a sub-feature of the mass properties analysis feature, so that's OK. And you can also see that the point has appeared on the model as well. That's because we have the point display switched on. So now what we're going to do, we're going to look at the model from the right, predefined view, and then we're going to switch on axis display, and you can see that currently the center of gravity is slightly away from the center axis of this crankshaft. So what we're going to do is we're going to create another analysis feature. So we're going to use the measure tool here, we'll do a distance measurement, I think, and then if we just open up our measurement selection window, if we select the point which is the center of gravity, hold down Control and then select the axis there, we actually get the distance between the two. Now we want to make this as a feature, so we're going to hit the save option here, and we've got make feature already selected, and then we're going to hit OK, and you can see that that feature's now been displayed in the model tree also. So we've got that distance of the center of gravity away from the center axis there. So the next thing that we're going to do is we're going to allow the display of these two of this distance in the model tree here. So we're going to go into the tools menu, parameters. We want to define the parameter, we want to look at the parameters inside of a feature. So we're going to change this first drop down to feature. We're going to select the feature that we're interested in, so it's this measure distance, and you can see that it has one parameter stored inside there, which is that value in millimeters. So if we OK that now, we can then go to our settings column here, and we go to tree columns, and we can add a column in there that will display what the current value of that is. So if we go down to feature, parameters, and just enter distance in there, and then you can see that when we apply that, we get a new column called distance, and it's showing us the current distance of that measurement. So now that we've set up that analysis feature, we can use that in some of our studies. So we're going to go into analysis, and we're going to do a sensitivity analysis and start varying some of the dimensions within the model to see how they affect that offset distance between the centre of gravity and the centre axis there. So the majority of this shape, this outline here of the part, is controlled with a sketch that's actually hidden, and the tutorial's telling us that it's in this lobe sketch that's been hidden. So if we want to just select dimension, and then if we select lobe there, you can see that the major governing dimensions for the shape of the lobe section become visible. And what we're going to do is we're going to go around these and allow the system to vary them and see how that affects that offset distance of the centre of gravity away from the centre axis. So the first one that we're going to allow it to change is this 2, this offset value there. You can see the dimension that that's controlling. It's essentially the step between the centre line of the part down to where this angled corner piece exits. So we've selected that. We're going to set a range that we're going to allow it to vary it between. We're going to set 1 as the minimum, and we're going to set 3 as the maximum. And then we're just going to hit compute. We need to set the parameter that we want to have on the plot first. So I've hit parameter, we'll select our distance measurement, and then we should be able to hit compute. And you can see that it's running through the different variations of our model, varying this in 10 increments. You can also see that that distance away from the axis does not vary a huge amount given the changes here. So what the tutorial is asking us to note there is that changing that dimension does not have a great effect on the offset distance of the centre of gravity. So let's go back in and just select a different dimension here to vary. And I think the next one that it asks us to select is this lower 25. So you can see hopefully what that is driving. It's driving the or it's similar to the radius. So we've got that dimension selected. We're just going to enter the range that it advises, so 20 minimum and 27.5 maximum, so we're happy with that, and we're going to hit compute. So here's the graph, and we can see how our varying this dimension changes that distance away from the center axis, and we can also see that it gets closer initially, and then we can assume that this is where it crosses the axis and starts to move beyond the axis but in the other direction. But more than that, we can see that this seems to be having a greater effect than the first graph that we saw, where we were varying this little offset distance here. So that's something interesting to note. The last sensitivity study that we're going to do we're going to select the sketch again. We're going to vary this top 25 value here, and again we're going to put the suggested range in there, so 23 to 32, and again we're just going to compute that and have a look at how that graph shows us how the distance varies. And again, it's having a reasonably large effect as we vary that value. So really from these 3 sensitivity studies, we can see that that little offset value, that one in there, has a small effect, whereas these two, the top 25 value there and the lower 25, have quite a large effect. We're going to do one last sensitivity study, but in this case we've turned the plane display on and we've made sure that the lobe front and lobe rear are set to unhidden. So they're initially set to hidden, but you need to unhide them so that you can see these planes. And if we look at this from the other angle, you can see that these planes are governing how thick these lobes are. So what we're going to do is select dimension again and select lobe front. That allows us to access the offset distance here for that lobe, and we're going to enter a range of 10 and 20 for the lower and upper limits. So we're going to see how the thickness of the lobe there affects where that centre of gravity is. And again, you can see from the plot there that it does have an effect, but it's quite modest. It ranges from 1.2 up to just above 1.9. So not quite as much as they vary in these 25 mil values. So at this point the tutorial asks you the question, which values might it be wise to try and vary to change the centre of gravity offset distance, or to try and get it down so it's coincident with the centre axis. And the conclusions that it draws are that that top 25 measurement and the lower 25 are the prime dimensions to be targeting, but that if you were to increase the top 25, which is what it would take to pull this centre of gravity upwards slightly, you would have to then redesign the whole of the inside of the engine that this crankshaft sits in. So it's far wiser to reduce the amount of material down here by lowering this lower 25 value. So you reduce the amount of material down here rather than increasing the amount of material up here. And the knock-on effect that that has to the assembly that this thing fits in is that you don't have to increase the size of the cavity that this crankshaft spins in. So that's deemed to be the wiser of the two options. So with that in mind, the first thing that we're going to do is a feasibility study. So I've selected feasibility and optimization here. By default you'll have optimization selected. We need to change to feasibility. You can see that for a feasibility study there is no goal as such. There are only design constraints that either have been met or haven't been met. So it's very much an on-off sort of decision-making process rather than a goal-based study where it's tending towards lowering or maximizing a particular value. So the design constraint that we want to add in here is based on that measured distance from the centre of gravity to the centre axis, and we desire that that distance be 0. So essentially we want the centre of gravity to be on the centre axis, and what we're going to ask the system to do, we're going to add a dimension in there, we're going to select the lobe sketch, we're going to allow it to vary the size of that bottom lobe, and we're going to allow it to vary between 21 and 24. So we're just going to deselect this add dimension option just by quickly adding design constraint and then cancel. That allows us to get into the options menu, and we want to ensure that we have graph constraints and graph variables selected here, and then we can hit compute. So here are the graphs that we've produced from that feasibility study, and hopefully you can see that our dimension has been driven down to approximately 22 mil, and the distance between our centre of gravity and the centre axis is approximately 0. So you can see that the feasibility study has returned a positive answer to whether we can find a configuration for the part that satisfies our constraint of having the centre of gravity coincident with the centre axis. So we're just going to quit out of the graphs there, and you can see that the model's been changed. So you can see this 25 has now become 22.09. And if we go to close our feasibility study, we get a little message saying, do we want to keep this change, or do we want to reset our model to its previous sizes? And in this case we're going to reset. So you can see the model jump back to as it was, so this lower dimension is now back to as it was. And the reason that we did that is we're going to create a full optimization study. And so it's going to be similar to the feasibility study, but in the optimization study we're going to try and minimize the mass of the part. So you can see that currently we don't have access to a parameter that is giving us the mass of this part, so we're going to set that up first. So we just need to temporarily quit out of there. I'm going to go into analysis and mass properties. I'm going to quickly generate a preview of the mass properties and then go into feature. Sorry, we should have changed that quick to feature as well. And then the only figure that I need out of here is not the volume or the surface area, I just need the model mass. So I can click on OK. You can see that new feature's popped up just there. So more than that, I'm going to go into the tools like we did with the measured distance. I'm going to go into parameters, go quickly down to feature, select the feature that I'm interested in, so it's this mass properties. You can see that within there it has a parameter called mass, and it's giving me the value. I think these are in grams, so if we just remember that that is called mass, we can add that in to the tree here if we want. We can add a tree column, and we're getting this out of the features, and if we type mass in there and then just hit apply, sorry, not apply, we need to hit the arrow there, and then if we hit apply you can see that we have another column just detailing what that mass figure is returning currently. So once we've set all that up, we can go back into analysis, we can go into feasibility and optimization study. At this point the tutorial asks you to create a fresh optimization study. You can do, you can delete everything that you've entered from the feasibility study, but we're going to reuse some of it in this example. So we want to base this on minimizing the mass of the part. The part still has to satisfy this design constraint. The center of gravity still has to be coincident with the center axis. We're still going to allow it to modify this lower arc, but we're also going to allow it to modify the position of this plane here as well. So let's add that in, add dimension, we'll select the plane, select the dimension that we want to allow it to vary, and then we'll set the limits that we're going to allow it to vary these between. So I think we'll have 12 for the plane, these are just from the tutorial sheet, and 16 for the upper limit. So again we still have this dimension selected, so a good way of deselecting that is to hit add up here and then just cancel, and then we just want to quickly check in the options menu here and just check that these three are selected, and then we can compute. So here's the completed study. You can see that we get some info in the message area down here saying the part was successfully optimized. And if we have a look at some of the graphs, you can see the graph for the overall mass here, and you can see it reducing down to the end. And again, the tutorials rather helpfully calculated that mass reduction in terms of percentage, and we've reduced the mass by 20%. Other things to note are what the 2 dimensions now are set at. So here we've got our large dimension down here that ends at this point here, which is around 22.2, and if we look at the model we can see that it's actually 22.18. And again, the plane has moved, so if we have a look at the plane dimension here, you can see that that's actually reduced down to 12 as well. So we've actually optimized the part whilst hitting our design constraints and reducing the overall mass. And again, as we quit out of here, it's asking us, do we want to keep these changes, or do we want to revert back to the part before the optimization? And in this case, we're going to hit confirm. We're going to keep those changes. So that's the end of the tutorial.